There are several potential causes of vibration and humming in a molded case circuit breaker. One potential cause is loose connections. Check all electrical connections, including terminals and busbars, to ensure they are tight and secure. Loose connections can cause arcing and generate vibration. Tighten any loose bolts or screws. Another potential cause is overloading. Verify that the switch is not overloaded. Overloaded switches can overheat and produce vibration. Measure the current draw and compare it to the switch's rated capacity. Harmonics can also create additional stresses on the switch, leading to vibration. Check the harmonic content of the load and ensure it is within acceptable limits for the switch. Mechanical resonance is another potential cause. The enclosure or switch may be vibrating at its natural frequency, amplified by the harmonics in the system. Add vibration dampening material to the enclosure or switch. In rare cases, the switch itself may be faulty and causing the vibration. Contact the manufacturer for further troubleshooting and possible replacement. Here are some additional troubleshooting tips. Firstly, check the switch operating temperature. Overheating can contribute to vibration. Secondly, measure the voltage drop across the switch. Excessive voltage drop can indicate loose connections or overloading. Thirdly, observe the switch under load and listen for any unusual sounds or vibrations. Finally, consult with an electrical engineer or switch manufacturer for specialized advice. When addressing loose connections, remember that even seemingly tight connections can loosen over time due to thermal cycling and vibration. Use a calibrated torque wrench to ensure connections are tightened to the manufacturer's specified torque. Over-tightening can damage the connection, while under-tightening can lead to loosening and arcing. When checking for overloading, consider that the rated capacity of the switch is often derated based on ambient temperature and the number of conductors in a conduit. Consult the manufacturer's specifications or relevant NEC tables, such as Table 310.15b16 and 310.15c, to determine the allowable opacity of the conductors and the appropriate derating factors. Regarding harmonic distortion, understand that harmonics are multiples of the fundamental frequency, which is typically 60 Hz in the United States. Common sources of harmonics in data centers include uninterruptible power supplies, variable frequency drives, and electronic equipment. Harmonics can cause overheating of conductors, transformers, and other electrical equipment, as well as voltage distortion and equipment malfunction. Use a harmonic analyzer to measure the total harmonic distortion, or THD, of the current and voltage. If the THD exceeds acceptable limits, consider using harmonic filters to reduce the harmonic content. When addressing mechanical resonance, identify the natural frequency of the enclosure or switch. This can be done using vibration analysis equipment or by tapping the enclosure and listening for the resonant frequency. Once the natural frequency is known, select vibration dampening materials that are effective at that frequency. Common vibration dampening materials include rubber pads, viscoelastic materials, and constrained layer damping. If the switch itself is suspected of being faulty, perform a thorough visual inspection. Look for signs of overheating, such as discoloration or melting of the insulation. Check for loose or broken parts. Use a multimeter to measure the resistance of the switch contacts. High resistance can indicate a faulty switch. When checking the switch operating temperature, use an infrared thermometer to measure the temperature of the switch enclosure and conductors. Compare the measured temperature to the manufacturer's specifications. Overheating can be caused by overloading, loose connections, harmonics, or a faulty switch. When measuring the voltage drop across the switch, use a multimeter to measure the voltage of the line and load terminals of the switch. The voltage drop should be minimal, typically less than a few volts. Excessive voltage drop can indicate loose connections or overloading. When observing the switch under load, pay attention to any unusual sounds or vibrations. Arcing can produce a crackling or buzzing sound. Overloading can produce a humming or buzzing sound. Mechanical resonance can produce a ringing or vibrating sound. If you hear any unusual sounds or vibrations, investigate further to determine the cause. When consulting with an electrical engineer or switch manufacturer, provide them with as much information as possible, including the type of switch, the load current, the harmonic content, the operating temperature, and any unusual sounds or vibrations. They may be able to provide you with specialized advice or recommend further testing. In addition to the above, consider the age and condition of the switch. Molded case circuit breakers have a limited lifespan and can degrade over time due to repeated operation and exposure to harsh environments. If the switch is old or has been subjected to excessive wear and tear, it may be more prone to failure. Consider replacing the switch with a new one if it is nearing the end of its service life. Also, check the grounding system. A poor grounding system can contribute to harmonic distortion and electrical noise, which can cause vibration and humming. Ensure that the grounding system is properly installed and maintained. Verify that the grounding conductors are sized correctly and that all connections are tight and secure. Consider performing a ground impedance test to verify the integrity of the grounding system. Furthermore, investigate the possibility of electromagnetic interference or EMI. EMI can be caused by nearby electrical equipment such as motors, transformers, and radio transmitters. EMI can induce currents in the switch enclosure and conductors, which can cause vibration and humming. Shield the switch from EMI by enclosing it in a grounded metal enclosure. Use shielded cables to connect the switch to other equipment. Install EMI filters to reduce the amount of EMI entering the switch. Do not forget to analyze the load profile. The load profile is the pattern of electrical demand over time. If the load is highly variable or contains frequent switching operations, it can generate harmonics and voltage transients, which can cause vibration and humming. Analyze the load profile to identify any potential sources of harmonics or voltage transients. Consider using power factor correction capacitors to reduce the harmonic content of the load. Implement soft starting techniques to reduce voltage transients during motor starting. Moreover, inspect the busbars. The busbars are the conductors that connect the switch to the electrical system. If the busbars are loose, corroded, or damaged, they can cause arcing and vibration. Inspect the busbars for any signs of damage or corrosion. Tighten any loose connections. Clean any corroded surfaces. Replace any damaged busbars. You should also check the surge protection devices, or SPDs. SPD protect the switch from voltage surges caused by lightning or other electrical disturbances. If the SPD are faulty, they can fail to protect the switch from voltage surges, which can cause damage and vibration. Check the SPD to ensure that they are functioning properly. Replace any faulty SPD. Consider the environmental conditions. The environmental conditions in which the switch is installed can affect its performance and lifespan. High temperatures, humidity, and dust can accelerate the degradation of the switch components and increase the risk of failure. Ensure that the switch is installed in a suitable environment. Provide adequate ventilation to prevent overheating. Protect the switch from humidity and dust. Another step to take is to review the maintenance records. Review the maintenance records for the switch to identify any previous problems or repairs. This can help you to identify potential causes of the current problem. Also, it can help you determine if the switch is nearing the end of its service life. Consider using a power quality analyzer. A power quality analyzer is a sophisticated instrument that can measure a wide range of electrical parameters, including voltage, current, harmonics, voltage transients, and power factor. Using a power quality analyzer can help you to identify the root cause of the vibration and humming. It can also help you to monitor the performance of the electrical system and identify potential problems before they cause equipment failure. Consider consulting with a qualified electrician. Troubleshooting electrical problems can be dangerous. If you are not comfortable working with electricity, consult with a qualified electrician. An electrician can safely diagnose and repair the problem. Finally, document your findings. Document all of your findings, including the measurements you took, the tests you performed, and the repairs you made. This documentation can be helpful for future troubleshooting efforts. It can also be useful for tracking the performance of the electrical system and identifying potential problems before they cause equipment failure. In summary, addressing vibration and humming in molded K-circuit breakers requires a systematic approach involving thorough inspection, measurement, and analysis. By considering the potential causes discussed, implementing the troubleshooting tips provided, and consulting with qualified professionals when needed, you can effectively diagnose and resolve these issues, ensuring the reliable operation of your electrical infrastructure. Remember to prioritize safety and adhere to all applicable electrical codes and regulations during the troubleshooting process. Also, bear in mind that this is a complex issue that may require the expertise of a qualified electrical engineer.